roll off
Huh?
You missed an exciting class earlier.
Oh yeah, what went on?
It's more confusing.
I don't even know if I'm gonna watch the lecture. I'm just,
Not like it's
that probably wouldn't even help me.
Yeah. Don't blame you.
I think not the one that I missed, but the one yesterday was useful when he showed us how to do that.
Oh, that's the only one that from start to finish I was kind of with it.
Yeah. Did he go over like anything like that? Nothing. Just kind of more abstract stuff.
Yeah, nothing hands-on like that.
Yeah. Oh man.
I think we're starting production now.
Yeah, I found that drilling homework too, so it's actually a hard one. Doesn't help.
Which one is it?
The 661, pressure calculation. It just takes time. That's the only problem. If it's in this class, it's kind of hard to balance the schedule. This is like a 10-hour credit course.
I've already crushed that.
Yeah.
Have a look at the drilling homework?
Yeah, that was kind of hard.
Really?
Well, not hard. None of this stuff is really hard. It's just it requires you to sit down and do it. Yeah, probably going to take a while.
I'm trying to remember which one that is.
I don't know if you...
No, you have to use two of them. I think the abnormal pressure and fracture.
Is that the Herschel?
No, not the Herschel calculation. It's the Ben-Eaton method.
What do you do for, I just kind of looked at it, I'm putting it off for the last second, but what do you do for your, calculation? So you have to know, if I remember correctly, you have to know your, what do you call it? Final ratio?
Yeah. It's all of them are given in the lecture slide. For the Ben-Eaton, there is a chart with depth and torsion ratio, and depth and overburden stress.
Okay. Are we supposed to like make like a or basically like an Excel sheet and then
You need an Excel sheet to work on it. Essentially, they give you a normal
figure that out?
section,
yeah.
and then an overpressure section. So you're supposed to extrapolate the normal back to the surface.
Okay.
If you use log
couldn't
or
find
log
it either, but-
work with an Excel, it will just give you equations.
Right.
Maybe I have to take into
And
consideration.
then you use the equation
From lecture 78 to calculate the pressure gradient, or pressure gradient, and then use that for to calculate the pressure gradient.
Gotcha.
It's a lot of, looking at the graph, marking the value, typing the value.
Yeah, I figured that. That's my I'll get a start on it due on Thursday.
Trio, I think they call this trio reservoir and test test, which means the gas.
Yeah.
So you need to use your specific per overburden.
I've never seen
Have you started the project?
This?
You guys are drilling project.
I think about 20 pages done.
Yeah, I get it.
My part is, I've only find one real mistake.
Yeah.
The other one is just bad writing.
Yeah. Unfortunately, I have a definition page, and all of them are wrong. Like, and there's like 50 different, like it has all the different symbols or nomenclature, and they refer to wrong equations that don't exist. So I have to go through the chapter and like check it for the equation that doesn't exist.
I'm really wondering if we have to check the mine has just like 5 reference pages.
Yeah, no, I'm not gonna check the references.
That's true.
Because I have like.
I like to learn that stuff.
Not doing that.
Yeah, like, oldest is retired, the lead is gone.
That statement quite a bit.
I believe it.
Okay, the, AC guys came in, screwed around with my air conditioning and broke it.
Not about material.
It's like 95 degrees in my house.
Hours, our plan, building open road.
That's why I came here.
Just,
Came
guys
here
are all
2 hours ago.
right?
Yeah, sleep here tonight.
I feel like he's the kind of guy who doesn't think like memorize.
I don't,
Yeah.
I don't really look up enough, but I think he
I can't even
said he was gonna get replaced because he doesn't understand.
Like his notes are pretty easy to understand. You know, exactly explain it.
Where's
Pretty long course.
If you look through.
You don't have right next to the gas station.
Say what?
If you have a problem with legislature, I should get
Where is
There's no radio in the front with the back.
Like write things down, have it in front of you, like refer to it constantly. Like no legislature,
Is it like the, is it in 2012, I think?
having a shoot.
Yeah, he doesn't solve all kind of that.
I can't remember which one it was, but yeah, I was looking
The
for it all the time.
inconsistency would be problematic, but as you said, that's pretty cool. The landslide.
Do you remember his?
So
microbrewery.
it is something that you have to look for.
Okay.
Oh.
What is it?
So,
Watch
yeah,
the lecture?
I think,
No, I couldn't get it.
no, 2007 or 12.
Yeah, apparently it was more confusion.
Now, did you see the discussion board? People finally start posting on the discussion board again.
Never looked at it.
Most of the people are clueless about what's going on.
Someone doesn't.
Yeah.
If you can't ask questions in real time, you're not gonna get to class.
We don't really touch on the situation.
Yeah, so the only one I found
Looking at
was
the
time.
Yeah, I thought it'd be more than.
How do I know this is one half? Yeah, so we have to know that
I know
the
there's
root
time,
C
but-
squared within the station.
What are we talking about? I mean, it doesn't have to be
They have
something.
projects.
The amount of material he's trying to cover is
Yeah.
impossible.
I feel like there is
He
only.
said it's gonna, we haven't started.
Yeah, that's what I was trying to do, is find some old stuff to study.
That's gonna cover it in, by today and tomorrow.
180 pages.
Okay, you should be happy now. That part out is on the classic setting and everything else.
So search engine is not saying anything.
No, I switched to Google Chrome, so now he gets to work on a preferred browser.
I know, he'll find something to criticize. Roughly.
It begins again with an alarm too, man.
8 p.m., man. We deserve a pizza or something.
We have 1 hour.
Oh, okay.
Yeah, I was gonna order a pizza and ask Jeffrey to help me out.
We have the,
What?
No, I'm just joking around.
I'll be on one.
they're making a problem like that.
About your $80 pizza bill. We're not, don't worry, we're not gonna let that go.
It was actually 64.
You round it up?
Plus $8 in split twice.
Oh, you.
Yeah, I know.
Let's get started.
The guy was happy.
Yeah, the guy was happy. You know what? It was
That's what
I charged Blasingame 72.
$16 for pizza.
There's 16 bucks for pieces.
No, that's terrible. Residual water saturation, residual oil.
The receipt wasn't itemized, so I don't know what they're charging me. I still have to.
Hidden fee, man.
Like, there was something hidden. I don't know what to do.
They only charge you for like the box. I had a homework over with,
Oh my
on
god.
the first day.
Oh my gosh.
Well, that was the only problem that.
Can't wait till this is over.
Maybe they still try driving mad.
5 more days. 4 more days.
5 more days.
4 more days.
Isn't it 1 more day?
No,
No, I'm talking about completing the exam.
Exam day.
Yeah.
That's the worst part.
Yeah, the exam is.
What's our job? Exam.
I really don't think Blasingame exams are going to.
If it's an exam, did he say?
Exam. If we have us for 3 days, we're gonna exam.
He's gonna have us do that graph window thing
Yeah.
during the exam. It's gonna be causing all confidence.
Yeah, real estate. Have the exam at night.
I use that software. The projectors.
You didn't forget, did you?
No, he
You're
just
still
made
on
up
your
saying he
own.
was stuck in traffic.
Really?
Yeah.
Very likely.
Traffic? What do you mean traffic? This city, traffic?
No, apparently he went to Houston.
Yeah, for some convention.
He's not gonna be back till about 11:30.
That's not
I mean,
good.
tomorrow we'll lecture literally.
Hook on it, like 11:30. Hey guys.
Email. Midnight lecture,
So he should be arriving 5 to 10 minutes.
To you personally, you should feel very special.
He's CC'd everyone else.
No,
Can we
he
just
himself.
find a spot somewhere else?
Himself.
That's cool, man. Joke time.
So apparently nobody else is getting this email?
Oh, he knows you're gonna log in.
And you get his mobile too.
Oh, yeah.
And everybody else gets his mobile too.
So,
everybody follows him about. Yeah, if you wanna go over, that's the problem.
they're not much longer.
Professor Blasingame, I have a question.
What?
No, I want to be like that. I would say something much better than that. You better be doing PA now, because otherwise, I feel like this is like freshman chemistry, where they go over everything, and then nuclear chemistry has to be 2 days. Like, anybody else have that? You, getting you. In freshman chemistry? Oh, okay, so you skipped it entirely, yeah. For our, the professor went through electrochemistry for about a month, and then said nuclear chemistry for a day. And that was retarded. He just kept on talking about, what was it, like the mercury electrode? Like, it has a special name, like calor something. Because it's incredibly stable. Mercury electrode.
I call it a thermometer.
No. Electrode. Like a galvanic cell.
Okay.
Oh, electrical tape.
No, it starts with C because it's Latin for something.
Calories and energy, and that's normally.
No, calorie is a French word. It was invented by a Frenchman.
Calories.
So what's the point of this?
Well, I went off on tangent, but the point was that that half of the course is now 2 classes. Well, 1 class and some fractions.
Jeffrey, are you still talking?
Yeah.
I left the room and you were rambling, and I came in the room and you're still rambling.
I'm not rambling.
Yes, you are.
No.
You want I can get my paper set up?
Sit down, Dennis.
You know, that would make it nice.
Oh my god, this sucks.
any of you guys first years?
First year in.
Pretty sure it ended in the spring, and the summer doesn't really count.
I started in the spring, so it takes it to the spring.
Yeah, so this is still the end of the first. Online, huh? What do you work for?
Small company in Austin. Small production company. We operate out of Midland.
Is there corporate headquarters in Austin, I assume?
We're not a big corporation.
It's kinda like
We got an office with 4 people in it in Austin.
Nice.
We got an office with another 4 in Midland.
Is it one of the companies that, takes over, like, the small lease wells that were drilled? Or do they,
We do some of our own drilling,
Okay.
and then, yeah, we're just, picking off little properties here and there when we can.
yeah, 'cause there's like a bunch of wells, especially like within Midland and whatnot, that were completed 40 years ago, and
Yeah.
but with our technology now, we can actually
Mhm.
economically produce them and still make them
Yeah, but
pretty
there's
decent chunk of change. A lot of big companies won't touch them either.
Like the Mississippian and the Wolfcamp up there are really starting to get hot. People are starting to figure it out. So that's what
Yeah.
they're trying to break into. But those are $5 and $6 million wells up there.
Yeah.
We don't have that capital.
Absolutely.
Or at least not enough to lose it in one well and move on to the next one.
I bet you guys are drilling single stand, little Derek, 30 foot.
No, we got
You got a legit there?
Yeah. We're not totally half at it.
Yeah.
All I could find.
Yeah, give me that.
That's painful.
Yeah, I actually need one of those, so I need that. Thanks. I actually do need one of those.
So I do it.
Yeah.
Mine now. You gave it.
I did not actually give it to you, you just grabbed it.
It's been 20 minutes.
Apparently there's a big grass fire going on.
What? Where? About that time of year.
Yeah, no, I keep getting emails from chief saying, we need help.
Is it
Like,
down?
nope, I'm not doing that.
Yeah, nothing new.
I don't think it's grass.
When he says leaving Houston,
I remember a couple of years ago,
No, you left Houston, it
it was
should
like
be
3
Yeah,
minutes.
what, an hour drive?
I think Blasingame is pretty careful with the
Like
leaving Houston.
Yeah,
Where were we
if it's
stuck?
traffic heavy, should get to Damo.
For like 3 or 4 hours?
He emailed you at.
Oh, okay, he emailed at 5:53 and then he emailed again.
Yeah, exactly.
Huh,
The first one was at 6, the second one
7,
at,
Wow, that's a lot of traffic.
You just day trip.
yeah.
Busy man.
It's like 3.5, 4 hours of driving already.
Depends on where they went.
That's true.
They went to Woodland, 7 to 3 hours. They went to South Houston, and went 4.
We got that one caught that way.
Nice.
Two?
But we're only with
So we got there around 4, 4.
And then, yeah, so,
And then we got right to
and what's the, how's Anadarko doing as far as Sean?
hey, you want this job? You know that.
I normally go on weekends.
Where's Rice again?
Just like PUH.
I think I've played in places.
west of UH, right?
I think so, about
Or
5 miles away.
northwest or something.
Yeah.
Because UH is right on 45.
Yeah, 45 is 45.
And then I think it's 610. Yeah.
Yeah, they're in a little bit nicer area.
Just a bit.
Yeah, UH is, right next to the top 10 worst crime rate neighborhood in the West.
2.56
billion
barrels.
Kansas is getting so big these days.
Billion.
UH?
Yeah.
No, it can't.
That's the
be bigger.
reserve in
It's
Antarctica.
been landlocked for
Where?
several decades.
I feel like it's
Or just like
Or
some
maybe
all
it's
over.
huge already.
Yeah, this is like that's obviously an estimate, probably an overestimate.
Okay, that's what it is.
Apparently, that's their producible
In any direction.
reserves available.
Yeah.
The
Lucky
maximum
for
is
the field
every
to have a
little piece of ground that they
200 or
have.
300
They have
million pounds
2 or
per.
3 parks that are, gravel.
Did you go to UH?
Yeah.
Okay.
I believe that's not Blasingame.
No.
He would have come in and,
Oh, he did. Hi guys, I just called out to Blasingame, he said he's on his way.
Okay, thank you.
Thank you.
Bye.
thanks, Lord, daughter. Neil, right?
Yes, we started.
Already. Blasingame. I don't know, what do we call those, like, Tattoo touching, or? No, like, they work, like, together, but separately.
They're colleagues.
Yes, but, like, they handle the same project, like, it's not half and half, but it's like
Co-workers?
co-directing the project. Well, they're all co-workers,
They're instructors?
Team members.
they're not really on a team, because it's more like between the meeting.
Oh, editor. Captain.
But it's, once again, it's not really a team.
Maybe they go on a military system, where they have first lieutenants and sergeants.
There he is.
And then,
Sorry.
Alex Carter.
The police don't like it when you pass them. Did you get my email?
Yeah.
Oh, so you could have told me.
Oh,
It's like, faster.
I got your one that was 15, 20 minutes ago, just as I got here at 8 o'clock.
Yeah, I was, making pretty good time until I got behind the policeman. You know how it is. Jeffrey, you should have been a policeman. I need to, Jeffrey, is this your apple core laying on the floor?
Yeah.
I think he was saving it for later. I was almost certain that it went into the bin. Almost 100%.
oh, it really was yours?
Yeah, I went during lunch. You saw me.
God, I didn't know. I thought it was
Most of his jokes are grounded in reality. He doesn't make shit up.
Where's the underground?
He commutes in Houston, so.
He lives in Houston right now.
Yeah. Saying something about how he commutes to Houston.
Is it actually locked?
Yeah.
Okay, so I thought we'd try something a little different tonight. I know we only have a couple of lectures left, but I'll also lecture over the problems once I'm done. You guys don't have anywhere to go, right? I mean, you're still here this week.
Where, Blasingame?
Sorry?
What do you mean?
Our last lecture is supposed to be the 7th, according to the syllabus, but I changed it. So like if I need to meet with you again, let's go over your exam.
I'll be here.
I figured that would be one of the. What's I thinking?
Trying something new.
Good guess. Thank you. It's not one. But I'll let you live this time.
You don't like my ruler?
No, I needed something bigger. Alright. So, let's be holistic. Forget symbols, and numbers, all this other stuff. Okay. Describe something that you can measure, that you want to know what the ultimate value of it is. Okay? So, what's that look? Alright. Let's say that we are going to have an inheritance. You like inheritance? Yeah. But you can't put it in the bank. Yeah, spend it. So what we're going to do, and maybe that's not the right way to look at it. What would be a better way to look at it? Well, inheritance might work. Okay, so your uncle leaves you a declining balance. Okay? And there's a bunch of numbers. Yes, I thought you'd like that. Why is it so green?
Declining balance, it's the same when they, let's say you won a lottery and they pay you in installments, something like that.
That's a good one. Okay, very good. Why did you keep writing?
Yeah, because you selected the mouth to be black, not pen. Yeah.
Okay, so time, what would you like to call it? Rate? I like rate. How much is the lottery tonight? Tomorrow night?
250 million, I think.
Something like that? Did you buy a ticket?
Yeah.
Really?
I'm a gambling man.
Like to go dangerously.
Let me know when I was considered. Okay, so at time 0, 1, 2, 3, 4, 5, let's say it's years. How much would you like to start with, Dennis?
$1 million.
Okay. So we start with 1,000, and then next year, what do you think you ought to make? What if it goes down by 50% each time? That part I understand. So 500, 250, 125, 67.5, not 67. 62.5, 31.75. This is embarrassing. Okay. It's been a long day. So, we have our rate, and then we have our time. We have 1,000. So that's 500, 125, 2.5. Did I skip something? No. 250, 125, 62.5. 31.25, like that. Okay? Okay, so I'm going to sketch in the curve. This is is a bad example because I used up all my space. So I'm gonna create more, if I can. You like that, Dennis? And what I would like to do is I'd like to figure out what the area under the curve is. I get paid all the time. It's not a block. Paid in the income. All right, so how would you extrapolate? What's your logic?
Exponential curve.
Why?
Decreasing by 2 to the power of n.
What's the definition of an exponential?
E to the power of negative a.
dq dt 1 over q is equal to some constant d, is that right? Negative? Does that look right?
Yep.
So that's 1 over q dq is equal to minus di t. How do we integrate that, Dennis?
You take the integral both sides.
Integral from q I q, integral from,
AI
right? What do I get? Natural log q over qi,
equals negative DIT.
is that right, class? Now what do I do?
Take the exponential.
That gives me q is equal to qi ext minus di times d. Any arguments about that? Everybody's okay with that? So there's your exponential decline. It all assumes starting point of here. Is this rigorous? Okay. Yeah. All right. For this case it is. So now, I drew this as a Cartesian scale. What would this look like on a logarithmic scale?
Log one.
So now I transfer it to a logarithmic scale on the y. What's it gonna look like? It's okay for me to be lazy sometimes, right? Okay. All right, so that's easy. Are you close to your mother, I'm sure? You call her every day?
Yeah,
Really? Every day?
twice.
Twice a day? It's pretty good. I don't figure she lives here, but maybe she does. Do you have to watch the clock?
Not really.
No?
Fine, yeah.
She's okay with that? You remember the first thing your mother told you when you were a baby? When you came out and she got to know you?
Don't remember exactly what
I
she
do.
said.
I know exactly what she said. She said, never extrapolate anything but a straight line. Never extrapolate anything but a straight line. Last time. Never extrapolate anything but a straight line. Okay. And then what do? You come to the bright lights in the big city, and you start extrapolating all sorts of things. Is that okay? I mean, what your mother tells you is law, right? Doesn't matter what I say, what she tells you is law. Never extrapolate anything but a straight line. Why is a straight line critical in this discussion?
Because it's what we use for diagnostics.
String stuff.
Jeffrey's playing with it probably.
Yeah,
See the box up? That's the box up is the closest I could find to tape.
This is really not acceptable. Okay. Sam, dude? Why use a straight line?
Gives you a pretty good idea of where it's going.
It's actually not bad. Be a little more vague.
A straight line as opposed to supposedly exponential. You can figure out a slope, therefore extrapolate with that slope.
It's going off the deep end. Drillers, what do you think?
Same thing you say, you can foresee what you're gonna get in the future. It's not gonna change, the rate's not gonna change.
Your detail?
Because it's easier.
Easier. Reach back and just, Sam, I am?
Why extrapolate with a straight line?
Yeah.
It's more precise.
Let me put it this way, if you don't tell me something, I gotta go back to Jeff.
It's more precise, I think.
Tomorrow brings 2 decibels. Yeah? Chemical engineer? Is the straight line gonna be conservative or liberal?
Conservative.
It means say liberal. Good. Now do you get it? If you're gonna make an extrapolation, it better be conservative. What happens if it's liberal? Is it better to be wrong underestimating or wrong overestimating? Why?
So you don't get in trouble when you're wrong.
This is your money. So you're gonna go out and buy something you don't have the money for because you expect your income to stay, according to the more liberal estimate. So when we're sitting here talking about estimating reserves or making production extrapolations or that sort of thing, the thing I want you to remember, because the thing that every young engineer does is he says, oh, I can just turn that coefficient a little bit and get a lot more reserves. What does that mean?
That's fraud.
Well, for once we agree. For once we agree. Knowingly estimating something to be higher than it is, it's an interesting word, it's a fraud.
Legal fraud.
So you're gonna get caught? By whom?
FEC?
They don't audit your books.
I
Somebody's gonna, I shouldn't say they're not gonna audit your books, but they could ask for a random review. You present, what's it called, G10 form? I forgot the name of it. It's not my
Look,
area.
10K is the
10K,
annual,
10K,
it's the
10K,
annual
yeah.
report, but it's not.
Yeah. But every year you get reviewed by an auditor that you pay. Are they gonna give you the answer you asked for? No. And you're gonna fight with them about how you might have gone a little bit liberal over here, a little bit more liberal over there, maybe just a tad liberal over there. Everybody notice what I'm saying?
This could easily turn into a political.
No, I never said conservative. Nobody ever underestimates. Not without somebody holding a pitchfork to them. I shouldn't say that. I'm sure there's an occasional underestimator. The analytical methods that we use, not these break time type extrapolations. The analytical methods we use, they tend to underestimate. Why? Because they're analytical. They incorporate the pressure and the rate and the time along with the reservoir model. And all things being equal, they will conserve mass, they will conserve this, they will conserve that. They're going to tend to be lower estimates. Don't ask me why. But 99 times out of 100, a model will underpredict, unless you just close your eyes and spin the wheel of doom and make it do something crazy, which happens. So why did I want to have this holistic discussion? I'm going to give you data, I'm going to ask you to make an extrapolation. It will probably be pretty obvious what I want. But saying that isn't necessarily being that. The other day, I saw a master's student provide, what they did was they gave the data set in blue to 15 of their friends in the reserves world and asked them to make an extrapolation. Okay? Except that they really didn't do that. They did this. And they said, make an extrapolation. What did they get? Say that's the right answer?
Right as it works for Ryan.
There was actually one that went back up. I can't really do that unless you're really trying. There are a few equations that will go back up, but they should be safeguarded. Virtually all of the estimates were overestimated. So this is human bias. And of course, these points were shadowed out. They weren't really shown. They weren't given. Now there's all sorts of statistical methods you can use that will, generate a population, do this, one-per methods and so on. A lot of people use that. Why? Because it's totally unbiased, right? So okay.
But the way you deploy them with bias too.
Very good. There's a brain in there. Bring the duck feet in. Okay. How do you feel about that? There's somebody out there going to watch this video that's going to be a reserve person. They're going to go crazy. They say, you don't understand. They're right, I don't. I'm a deterministic person. I look at the data, I make a very objective, yet focused evaluation. 9 times out of 10, actually more like 99 times out of 100, I use diagnostics. I don't just use the red curve or the green or the blue dot. I use their derivatives, I use other functions, I use cumulative of that. I match them all simultaneously. Why? More functions, more resolution, more consistency, better estimate. Okay? But most people are going to walk up to the software, they're going to fit a curve through it. They're going to go, lunch. Yeah. Then, what about other models? How many different models are there that you can think of? Exponential, hyperbolic, harmonic, those are the big three that all come from the arc family. What about power law model, stretch exponential model, Long's model, logistical growth model, other population type models? Okay. What do they all mean? Nothing. It's just a curve fit. What's the best thing to extrapolate?
Straight line.
Yeah. Can you force everything to be a straight line? That's a trick question. Can you recast a given function into a straight line form? Have you done that? Take something that isn't straight line, but then manipulate the data via some formula and make a straight line out of it? Should we do that here? Yes, sir.
It depends on whether or not the governing equation behind it is linear. Okay.
Or it can be linearized.
Correct.
Even the hyperbolic equation can be recast in a semi-linear form. And I say semi because you have to know the answer to get the answer. You have to put the answer into you have to normalize based on a coefficient you don't know. All right, so everybody's comfortable with this? Dennis, if you were me, would you stop now, or would you try to go on ahead and talk about reservoir model?
You made it this far, you might as well talk about that one.
Okay. What's going to happen whenever I add pressure to this? Because right now, there's only one variable. R is equal to a function of T only. Is that the way it's supposed to be? No. Implicitly, we're saying that P, whatever that P is constant. Okay. Everybody happy? Yukito, you okay? Or should I call you Nikki? Are you okay? What did I tell you, damn it?
Well, you can't copy this because it's always smarting.
Yeah, I know, but I'm trying to kill them all. How do I kill them all?
Clear smarting.
Yeah, but where's it at? How about HUD? I thought it was Microsoft Inc. I wasn't paying attention. Okay, I got it. No HUD.
Yeah.
For a week. Alright, so let's do this. Dennis wants to add pressure. Thank you, Dennis. I was being facetious. I was quite old before I didn't realize that meant full of excrement. Some lady called me that when I was a kid. Are you okay?
I never thought about that.
Yeah. You weren't from Louisiana. Okay, so here's rate, and here's pressure. Time. Let's have a quickie. Ready? Rate goes down. What's pressure going to do? It's going to go down. What happens when you see this? One of them wrong. You guys remember SpongeBob? How does he do it? Which one's wrong?
Pressure.
We don't know.
Pressure.
We don't know. You know what I saw a couple months ago? Like that. You know what happened? It was actually more like they were trucking oil out, and they forgot to subtract the set of tanks next door. We're supposed to do this. They added the neighbor's oil. Remember, this is the guy who just tried to clear the ink off the page, and I got a PhD. You know, there are people that make legitimate mistakes, and they don't get corrected. These 3 data points were errors. Just for 3 days, they trucked the oil off the neighboring lease along with this and didn't separate them. So this is junk. The right answer is here. Did they go back and fix it? Nope. So anytime you see something like that, you better annotate it. What does annotate mean, Neil?
Highlight.
Put some text on it, put your name on it, put the date on it, and make it blood red with a yellow background. That looks good. Alright, so why did the boat go down? It's a decaying system. Okay? What we thought was supposed to happen was what, Sam, number 1?
Right, yeah.
That's not what happened then.
What P is this?
This is the pressure in the well. It's the only one we can measure. Good point though, it could have been at the manifold. That happens too. Sometimes people record the separator pressure. They record the line pressure downstream of the system. All these things have happened to me.
By design or?
No, just not paying attention. I was in a meeting recently where somebody was screaming that we must measure downhole pressure. In that webinar I gave today, I said we must measure downhole pressure. How many people do it? Practically nobody. So we have a pressure curve and a rate curve. How do we link these? What's the connection? Nikolai?
Darcy's law?
Louder.
Darcy's law?
That's a good guess. Darcy's law is part of it. It's a black box, right? Dennis, do you remember the black box? The reservoir model. So what we can do is we can take the individual pressures and we can use the reservoir model and we can project these up here, and that'll give you this black line. Okay, so you take these pressures and you run them through the model and they give you the black line. What's going on in the world? I didn't watch the news the last couple of days. Where's Snowden?
Russia.
Thank you. Yeah, he was in China. We should have left him, right? How come they gave him up?
Probably because they already copied all his hard drives and he was no longer useful.
You're smart. So when you steal secrets, what are you going to do, Jeffrey?
Pray for my soul.
Because when you get caught, they're going to eat you for dinner.
Yeah, there's no counter superpower anymore. There's no safe place. Depends on who I steal it from. Probably shouldn't steal it.
It's a really good point. Where could you go to be safe?
From the United States, probably no.
What about Iran? North Korea?
No.
I'm sure you'd be welcome there.
North Korea.
Sorry?
North Korea, yeah.
Yeah. Axis of evil. Iraq, Iran, North Korea. So what was France?
Not our fry.
No. They were the axis of weasel. You like them? That's not my phrase. A friend of mine who's French. He didn't like it. Okay, so we're gonna carry these down, and there'll be a calculation based on that. I know I've used black both times. Perfect match. You like? Don't like? What do you think?
What does arrows represent? What does arrows represent?
Arrows represent going through the model. So I guess I should have used a different color. My apologies. Can't use blue. I can use green. Isn't that right, Ruby?
Perfect model, perfect matches, I'm suspicious of because we don't know all the whole chemistry or the,
Don't say downhole chemistry. You know what happens if you say downhole chemistry in the real world? They're gonna smear you in pipe dope and throw you in the mud pit.
There is downhole.
Am I right?
Yeah, most probably.
Sorry?
There is downhole chemistry.
You just keep repeating that. You might want to take some spare clothes and some grease solvent.
Okay, we don't know all the reservoir spectroscopy either. All that stuff.
Throw me a bone here, drillers. Alright, so what would happen is you would take the black squares and generate the green line, and you would take the black circles and generate the red line, okay? Or, sorry, the black line. So that, the black circle down here generates the black line. And the green, or the black squares with the green line generate the green line. Okay, so we're going to generate a quick forecast. We need some pressures and some duration. Let's do rates instead. What was your favorite rate there? How long? 8,800 days per year, right?
What?
8,800 hours per year. That's 2 days. Alright, so that's time in days. And they want, incremental, so this is 50 everywhere. That is one thing about this software that's kind of annoying. Okay, what's your favorite rate? Hmm?
100.
Sorry?
100.
And then, like that. So now we'll take these, put them in here. Hit OK. And what's permeability? Make it 1.
0.6.
Thank you, Mr. Spock. Okay?
More logical.
And so there's your rate step, and there's the pressures. How do the pressures go up? Or the dentist? Why did they go up, Lance? What's going to happen now? Take a guess. It still sort of go up. Sorry?
In a lesser degree. So the permeability specified can actually give a slow decline.
Okay, so you want to change the permeability? Be lower or higher? How come they keep going up?
Is the Q supposed to be declining in a,
Yeah,
far higher?
they're pumping a constant flow rate, so they have to increase the pressure to keep on pumping at that rate. The volume in the reservoir depletes.
I don't know. Hmm?
Is this reservoir pressure or ground?
Hmm?
Is this reservoir pressure or pressure at the
That's
top?
pressure as well.
Pressure as well.
Yes? So let's do 500. At 100 barrels per day. What's going to happen? So what's happening is that at that rate profile, the steps are so small, that what's going to happen? Okay, well, let's do it the other way around. Let's check the software, since you don't believe it. Check the press. What's your favorite pressure?
2,000 PSI.
That's going to be wrong.
You have to have start pressure and then end pressure.
doesn't like that.
So what's up?
Hmm? So that's the constant pressure profile, right? Now I take the constant pressure profile, and what do? Okay, in this case I use the date. There wasn't much of a rate. Why isn't the rate very high? Because I dropped the permeability to a really small number. But what I'm really trying to show you here is that, okay, this is the constant pressure response. These are the rates that came from it. I was going to put these back in, these times and rates, and then generate it and show you that it would reproduce the constant pressure response. But what I really want to do is what? Okay. Let's do this. $8,800, right?
87.2. I mean, 87. 365.
Okay, what's your favorite equation? That? 100 times EXP minus 0.1 times G oh, that died too quick. So at the end of a year, it's 42 barrels a day. Now, if I've done this right, what should happen? Sorry? Tell me, class.
Pressure should be constant.
Concentrate almost similar after that.
You think it's going to be constant?
Constant pressure.
No. Do you think that whenever we put this in, it's going to generate a constant pressure case? Is it working right? At least, I guess these are durations, right? What's going to happen?
Pressure.
Think? Drillers?
question that, okay, what, so that's a pressure drop, right? Is this a pressure or a pressure drop?
Pressure.
Okay, so, okay, large pressure drop at the wellbore and and the pressure drop becomes smaller as you go away from the, like,
What does your simulator assume is a decline?
Simulator's not assuming anything,
No?
just running, taking whatever you tell it and doing it. Why isn't the pressure constant?
This isn't like a trick question where the simulator is something that is tricky, right?
We use an exponential decline, which should be constant pressure,
Yeah.
but the transient part is not. Right?
So there's a,
Any idea?
still transient after a year?
Hmm?
Still transient after a year?
No, but it's gotta get back to that. How long do you wanna run it?
So why don't we just make the permeability higher, make the runtime shorter? Sure.
What happens if you change the initial, pressure?
Hmm?
What happens if you change the initial pressure so it's not starting
It's
to?
not gonna do anything in this case.
Okay.
Now it's almost constant. Why? Because it's in millidarcs, it goes into this steady state quickly, and that's the pressure profile. There's a lot you can learn from playing with simulators. Hmm?
So what's going on with transient?
Well, you're the one that said it increased permeability.
Right. And the,
Why is it almost constant now?
because it hit to a steady state. Right, but why would the transient be?
The transient lasts longer with the lower permeability.
So it's assuming the well is starting to start up rather than the constantly flowing? It's assuming that the well is
It
starting to
assumes that this is the first rate, this is the next rate, this is the next rate.
Yeah, so you can't really get data from the constantly flowing well.
Hmm?
You don't get data from the constantly flowing well. You have to start from whenever they start up the well itself.
I don't understand.
What I'm saying is, you can't say, okay, we're starting here, we've had a history of flowing, but we haven't shut down, and we're starting with this pressure and we're going forward. They're assuming that it starts whenever the well starts flowing.
Correct.
Yeah.
Oh, let me delete this. Is there a faster way?
Could you say enter for okay?
Hmm? No, there's a browser. You can come into the browser.
So to make a projection of where, when the transient begins or when the transient ends, the simulator needs to have an idea of how big the reservoir is for flow.
Mhm.
Okay.
Okay, so these are the only data we currently have, right? I cleared everything out. Now I'm going to take these data and I'm going to extract them. Here on the plot. gotta remember to reset things. Okay? So where's the transient, where's the pseudo-steady state? Okay, this is a derivative,
Oh,
alright? This part is horizontal. What does that tell you? Tells you what the permeability is. That's the way the software works. What does this part tell you?
the boundary.
Tells you what the volume is. Obviously, you don't get to use software in this course, but there's the permeability, there's the volume. Okay. This is the pressure drop. This is the pressure drop derivative, just like a well test. This is the rate formulation. This is the integral of the rate, and this is the derivative of the integral. Okay?
Derivative of the integral.
Louder?
Derivative of the integral.
Yes.
So that's
Set up that way. Okay, this one is called normalized pressure integral. So this is the time average pressure drop here. It's also got rate in it. Time, if you integrate delta P over Q and normalize it with time. So it's the time average value of that. And then this is its well testing derivative, right? This curve is the rate divided by the pressure drop. This is the integral of the rate divided by pressure drop divided by time, so it's the time average function. And this is the derivative, the well testing derivative of that function. All of these are the same data. The core of this is the same. The master is probably easiest understood to be the sensor curve because that's the rate divided by the pressure drop. You can turn this back to the regular function. So this is pressure drop, and this is pressure drop derivative. Why is there some noise in it? There's always noise. This is numbers. It's used to calculate derivative. So we say smoothing. This is 1/10 of a log cycle. Now it's 20% of a log cycle. What's going to happen is if you keep increasing it, you'll over smooth it. Okay.
That's what the integral did.
Louder.
You said that's what the integral did.
The integral is now being plotted. It's very smooth. That's the whole point. And it doesn't matter whether you use one or the other. It only matters that you're consistent. The way this software is set up. The way the other companies set up is they only work on the function you tell them. But all of this is noise. This is just diagnostics. I'll walk you through it all. But we ran a simulation, and that simulation gave us a funny looking rate curve and a funny looking pressure curve. Up till now, there's nothing we can do with that. But there is no model being projected right now, not yet, on this data set. But what happens when I do project a model? The whole purpose of this discussion was to explain to you, recall, this is your pressure, this is your rate, this is your pressure, okay? You don't like this, right? Dennis? If you were me, what would you do to demonstrate this? Come over to the Excel file and do what? Okay, you would come over here and you would cut and paste these two columns, and then you would say this is equal to that, right? And you put parentheses around it, you put your glasses on, and what's the total amount of variance you'd like to see? 20%?
Sure.
So 0.9 plus what? 0.2 times what? RAND. Is that right? And what will that do for me?
It'll give you a
It'll give me a random number between 0 and 1. I'll multiply that random number by 0.2 because that's my range, and then I'll add it to 0.9. So if it's 0, then it's 90%. If it's 1, then it is 1.1%, or, sorry, 110%. Okay? Is everybody all right with that? So now I'm adding random noise to this. And of course it changes every time because it's not static. And I'm going to copy this, and I'm going to paste it. And I'm going to come over here. And unfortunately I'm going to have to kill all this. That's all right. I'm going to come back over here. I'm going to do this. Put these numbers in, run, okay?
Peckovich, what is that?
Mm-hmm.
What's a Peckovich file?
It's just a plot of one function.
Oh, Blasingame. What do you
Got
have?
your name in the single.
Can we see that one? I haven't seen the Blasingame pattern.
You've been looking at it for the last 10 minutes.
Oh, it's the one that, crazy.
All of these are Blasingame curves right now. The log and the Blasingame plot. What we were working on. Okay, so I added a significant amount of noise to the data. Correct? And look what it does. It generates little build-ups and drawdowns according to the data. Abhishek, do you wish you'd been here earlier than now? Are you glad that our paths crossed? So you can see just how irritating I can be?
What does that?
Okay, so all I did, now we have the random rate profile, the corresponding pressure profile, the so-called log-log plot, the so-called Blasingame plot, and there's no analysis yet, right? All we've done is taken raw data, here's random rates, random pressures which correspond to that, and when we process that data, it looks like it's been made into an equivalent constant rate case here, and sort of an equivalent constant pressure case here. Why? Because that's how I formulated the problem. All right, so what happens when I go to model and hit bang? Any ideas? It's going to draw a curve through here, it's going to draw a curve through here, it's going to draw a curve through here and here, and what's going to happen?
The noise is will be gone.
Well, if we've done everything right, that's what should happen. Why is it perfect? Because it remembers that was what we used to generate it. So it used the green dots to generate the red line, it uses the yellow dots to generate the green line. There's no error in this data because I gave it the rate and generated it from that. So it reproduced exactly what we gave it. Now, if I had provided the rates with error and the pressures without error, that kind of thing, then we would see some noise in this analysis, which is what would happen in the real world. But both of these are exact, so it's just going to reproduce it. The question I really have is, what do we do with these rates and pressures? The only way to analyze rate and pressure data is to tie it together with a model. That's what we're doing here. Now, the way I'll teach you how to do it is using a type curve. Is there a type curve on here? Technically, no, but actually, yes. Both of these plots project a model, so that's technically a type curve. You're saying, I don't know what you're talking about. Okay, well, let's run it a long time. Okay, so now I'm running it a really long time. generating beyond the scope of the data. Okay. Why is this so fast? Any ideas? It's an oil case. It's a liquid. It's a direct solution. If it were gas, it would take more. So you can see I've generated the model through all of the data functions. And again, I know this is very abstract. I know it's the first time you've seen it. I know it's got my name on the software, so you're like, oh, this guy's knows what he's doing, and we'll never figure it out fast. This is easy. What I really want you to understand at the core of it is a rate and pressure profile. Everything is taken from that. Now, what if you want to do just rate time analysis? They have a product called the arc plot, and the arc plot does an auto fit. This data set was originally what?
Better.
It was originally an exponential. Is this an exponential? No.
I don't know, yeah.
Where's the, I never use this anymore. What's the model do that? Hmm? Is it up here? Where's the B value? Oh, it is 0. Okay, so it is a straight line. It doesn't look like a straight line. Alright, what's your favorite B value, Dennis? There's 0.5, so that's too high. Using the arc equation with a B value not equal to 0 means the data curves, or the model curves. What's the rule on extrapolation?
Straight line. I forgot how to make it generate past the thingy here. I really need to use the software more often. Hmm? Annoying, isn't it? Okay, so there's the extrapolation. Not very good, huh? What's it look like when I said B back equals 0?
Okay.
That's good.
Okay? But you're going to be so tempted to say, you know, let me just give it a little push. How much difference does that tail make?
Point, well, considering the time value, it might not.
I think they doubled the time.
Well, this is how many million barrels you made at abandonment with that number. You don't make even a fraction of that, right? So you really have to be careful when playing around with this. This is not a particularly good ARPS method. It's programmed by French people to do, it's just basically an equation on a page. Yes, sir?
I'm still confused on what we're supposed to take away from this.
And that's what I wanted. I wanted you to be understanding that there's an almost infinite amount of things we can do with software and modeling, etc. But all I really wanted you to get out of this is that the root of it is this. We have a pressure curve and a rate curve. And then when you go to the software, which you're not going to touch in this class, it's just going to do whatever you want. And the more you want, the more it'll do. There's almost nothing. You didn't ask, what was the reservoir model, Abhishek?
Circular.
The reservoir model was a bounded circular reservoir. But what about a fractured horizontal well? What about a rectangle or fault or all these other things? All these models are in here. This is why I don't let you play with software. You can just start touching and tapping things, boom, the whole world. There's a near infinite combination of parameters you could use here. Now, I will teach you how to do the simple kit. I'll show you how to take a set of rate and pressure data, process it by hand, analyze it, and so on. I usually wait until well after this course is over, or after any course is over, to demonstrate software. I had a well testing exam one time, and just to show, I threw the data up. It was a regular field data case. I threw it up in the software just to show the class, and one guy went ape shit berserk. Pardon me for using bad language. I apologize. That was not the word I intended to use. And he goes, we spent an entire semester on something we could have done in 5 minutes. And I said, but now you know what's behind the machine. And also, is this software or any software infallible? Of course not. They made compromises along the way. What compromises did they make? For speed. Another thing that we didn't talk about, what's the radii? 5,100 feet, right?
They give you what, the errors that they use, right?
It also has, no, they also have a numerical model. So you can generate a numerical version of this. Double click on the boundary, set it as circle, make it 5,080 feet. Say apply, okay. Come over here, turn the grid on, that's the gridding. Is that enough? Yeah, why not? Go back over here, say, I want to do this with a numerical model. There's a numerical model. What went wrong? Nothing. Like I said, you know, how many people a day use the software? Thousands. It's in use all the time. What are people doing with it? Making projections, making analysis. The hard part for you is going to be when we get to unconventionals, because unconventionals, everything happens very slow. You're never going to see pseudo-steady state. All this analysis that I've just shown you goes out the window. You're going to have to be really careful using this kind of software. Yes.
How reliable would you say?
In terms of the machine, probably 99%, maybe more. As a machine, as a tool. You know, if you're asking me, is it a ruler, is it a hammer, is it a calculator? Yeah, that part's fine. But you can't just walk up to it and give it numbers, you know? So let's go back to the numerical model. You ready? And let's change the numbers. What's your favorite number? 2,500, 10, 4, okay? The answers are garbage, right? They're not even close. So what do? You walk over here to improve, which is French for cheap, and you say, go solve this for me. Is it going to find the right answer?
No,
I have no idea. Probably not, but it might.
we don't have.
Hmm? Do you understand? I don't want you to do this. I know it's like showing you a toy and then not letting you play with it, but you got plenty of time to play with it after school. You play with it during school, it totally corrupts the lesson. Yeah.
Kind of curious, actually going on your point about like playing with a toy, why do you, or maybe this is kind of an irrelevant question, but why do you present the course with this at the end? Or I mean, did you typically?
I never show the software.
Oh.
I did it tonight
Okay.
so that I could explain to you where a rate and pressure curve comes from. I wanted to be holistic about it, and I wanted to jump from something that was totally tangible to something that was totally abstract, so that hopefully I have your attention span now, and that whenever we spend the rest of the lecture tomorrow talking about production data analysis, you're going to understand in the back of your mind that there's a tool that can do this for you. But this tool cannot think, look, it's going nowhere. All I did was modify the values, totally corrupted it, and it can't do anything. There's the answer. Okay? Why didn't it nail it? I don't know. It actually got a lot closer than I thought. To quote that 70s love song, let's do it again. It'll probably get it this time.
Why did you unclick that variable? What was it again?
Huh?
The variable that you unclicked.
Initial pressure.
Oh yeah, because we already know what initial pressure is. What's it not matching?
The derivative.
It's not matching the permeability. That's the biggie, it should. That's the easy one. The wrong answer is being presented as right. Do you know why it missed it? Since we're abstract, it's because not all the points are being used. Okay? Because the software automatically picks a sampling of points. I'll pick them all, and I bet it will nail it. But this is a trick problem. You know, we already know the answer. You cannot walk up to this, turn it on, and say, give me. It's not going to work. So getting back to the holistic, I want you to look at that rate and pressure sequence, and I want you to ask yourself, what's wrong with it? Because what's going to happen when this model hits an error in the rate and pressure sequence? Nothing. It's just going to keep going. It has no idea there's a problem. It's not smart. It's a machine. It doesn't know that there are errors in the data. It doesn't know that there are things that you know that it doesn't. It didn't come out right, but that there's a corruption. It hits the corruption. It just keeps going. It's just a machine. And the same is true for the other vendors. The other vendor uses type curves. Type curves are suites of solutions like this. This is a whole bunch of different solutions. Okay. All right, so we're going to stop this because I've really, really messed up. I shouldn't have. It doesn't exist. Poof, it's gone. Okay. It was just a dream. All right. So we come back and we talk about the holistic rate and pressure data. Can you ignore either one? No. And in a way, this is exactly like well test analysis because we have to know both signals. We have to know both signals. But in well test analysis, we usually assume that the rate signal is perfect and we're working on the pressure. In other words, the rate is given. Here, both rate and pressure are given. Now, could we, in theory, import this variable rate, variable pressure data into the well test analysis package and analyze it there? Yes, in theory, we could. But the well test analysis package uses specialized plots which assume that everything is okay. And what do you think is going to happen when you send it multi-rate, variable pressure data? It's going to go crazy. because it's not designed for that kind of analysis. It is incorporated into that. But if you're going to be looking at a near infinite variation in rates of pressures, you may as well go to the other package. That's the purpose of the other package. The purpose of the well test analysis package is you have a single constant rate producing, bang, it's shut in, and you analyze the pressure. Now, can it handle the other stuff? Of course, it has the same engine. But it doesn't have the same analysis protocol. It does not like having an infinitely variable number of rates. It's not set up for diagnostics that way. The other one is. Okay, so as you sleep tonight, what I want you to think about is we're going to take the rate data and we're going to fit a time-dependent curve to it. What does that mean? It means that we're going to fit an equation and that equation could be Q is equal to QI 1 over 1 plus B DI times T to the 1 over B. What is that? That's arc, sorry, didn't use capital letters, and it's his hyperbolic relationship. What does the theory say, Dennis? The theory says that B must be less than or equal to 1. Do you know why? It's interesting because there's nothing really that says it's supposed to be. Somebody tell me something. You ready? Okay, I'm going to switch tools. I'm going to go into the Adobe Acrobat file, and I'm going to show you something. No. You go through the important ones. Okay, Dennis, this is the rate equation for the hyperbolic, and I said that B has to be less than or equal to 1, right? Here's the hyperbolic, B less than or equal to 1 human production, right? Is there really a requirement that B has to be less than or equal to 1?
No, it simplifies.
No. Look at the equation and tell me, does it affect anything here? No. What happens here?
Wow.
What happens is the second that B is greater than 1, this goes to infinity. It's a weirdo equation. It's got a glitch. The second that B goes to greater than 1, or 1 or greater, it goes to infinity. There's a way around this. You just don't carry it out to the full term. You don't, the integration is not implied to go to infinity. And so you just stop, right? There is nothing that says that B has to be greater than or equal to 1, or sorry, less than or equal to 1. But if you look down here, this is the so-called Bekovich type curve, and what I've done is here's B equals 0, 0.2, 0.4, 0.6, 0.8, 1.0. There's 1.25, 1.5, 2, 3, 4, 5, 6, 10. There's nothing that stops the equation when B is greater than 1. But guess what the interval is? Infinity. You already saw the equation. So all this time, before unconventional, we always stopped. We always stopped with B at 1. The theory told us that there was no bona fide reason why B should be greater than 1, right? Okay? You guys like tricks? Do a trick for me, Dennis. Who can do a nice trick? Everybody? Oh, great. Not really what I had in mind. This is Sniffer. I hate Smith. I want something better. You like?
Some smart things.
Yeah, yeah. What am I gonna do, Dennis?
Just read it.
Okay, sexy, right? Everybody? So why are there values of B greater than 1? Yukito? Well, 70 is our love song. Get right back where we started from. Love is good, love can be strong. I'm only going to take this part, right? Abhishek, do you know what I'm about to do? Can you do the Jaws music for me? What was the size I made this puppy?
95.
Wow, you got a good memory. Okay? Let's make it transparent. I can't believe I did that. That is embarrassing. You know what it's like when you go nuts? Anybody want to comment? Anybody else? Jeffrey? No hot English, man? You like watching the old man go nuts, right? Are you going to put me in an early grave? Probably not.
I thought Mrs. C was doing that.
She probably will. Doesn't really match, does it? Okay, you don't like that one? Annoying, isn't it? There's a fractured well.
What's that wish closure?
It was a constant pressure case, but we modified it. $95, right?
Yeah.
I hope 95 is correct. It doesn't look like it. Yeah, I would try. Dang, not bad.
Bring it up to the
I
front.
got it, Abe. Not bad, huh? I mean, it's pretty close. Scale-wise. Am I right? Yeah? Okay, so my contention is that these dotted lines over here, they belong over here, not over here. All right, they would be over here, right? But they belong over here. Do you see?
Why? What are you doing?
Okay, the B equals 2 is right here. Linear flow is here. See how it fits?
Yeah, but
You guys following this?
At least we saved it for us.
Here, I'll make it fat. Now, obviously, the curved part isn't gonna match. Why does it do this? Why doesn't it just do what I tell it? Favorite color?
Red.
Alright, so now I have this. See? See how it overlays? Not this part, but this part.
That's the slope?
Yeah. The b equals 2 hyperbolic is the same as linear flow. So we're on the wrong part of the graph. We were down here, and we thought that, okay, so what Benjamin said is still true now. What he said was anytime you see b greater than 1, then it's transient flow. He said that almost 40 years ago, and everybody ignored it. They've been using whatever they wanted. But in fact, what he was trying to explain is that this part of the curve is supposed to be over here. When you see a b equals 2, that's really over here, not over here. Does everybody understand? This is a fractured well-type curve. The slope of this trend is 2.
One half or 2?
What's that?
1/2 or 2?
Oh, sorry, it's 1/2, thank you. b equals 2 is slope of 1/2.
Yeah.
How do I know? Go back to the equation. When you substitute 2 into here, what's the long-term behavior? Half.
Square root.
Right. So all of these curves that match the b equals 2, they're all linear flow. This is a fractured well-type curve. What did we learn today? What gives you a slope of 1/2? Infinite conductivity. That's why we went through that exercise today. Okay? So when you see somebody using a b value greater than 1, they better be talking about transient flow. Transient flow is the left side of the curve, not the right. Transient flow is the left side of the curve, not the right. I'll say it one more time. Transient flow is the left side of the curve, not the right. By definition, if you have transient flow, can you estimate reserves?
No,
Why?
you did.
You already know b equals 2 has an infinite extrapolation. B equals 2 here will have an infinite extrapolation. You can stop it, obviously, which is a lesson that it took me a little while to learn because I'd always worked on total behavior. You can truncate, you can stop it, which is fine, and that's what we do. Is it square root the whole time?
Oh no, you have to.
It falls below the line, and when it falls below the line, it means it's no longer square root. So extrapolating a square root, when it's not, will be an over or under estimate.
Over.
Over. It will always overestimate. It's okay, getting holistically back to where we started from, it's okay to underestimate. It's not okay to overestimate. This methodology, where you're matching transient flow and making extrapolations, you're going to overestimate. And you're forgetting all of these are log scales. So this difference is huge. The other day somebody contacted me and they said that they had made a reserves estimate for a single well. And what was their estimate?
The amount, well, Saudi Arabia has.
It was essentially the amount of gas that New York City would use in a day. Okay. Actually, sorry, in a year, whatever. It was 500 BCF. 500 billion cubic feet. That's 1/40th of the United States consumption out of one well. So, he goes, oh, and this is an algorithm or an equation that basically extrapolates this square root trend. And he goes, hey, I got it, to give me a more reasonable number. I said, okay, what's your number? 50 billion cubic feet. I said, give me that. And I looked at it. Everything I could do, all my skill, all my effort, I got it down to 5. The right answer was 1. So, complete novice applying something, 500 BCS. Off by a factor of 500. It's going to happen to you. You're not going to be paying attention. You're going to do this. And hopefully you'll be by yourself and you'll get a cold chill and you'll go, oh, I shouldn't have done that. Before you go to your manager and go, I just found $4 billion. Okay, at current prices, it'd only be 2, but you get the message. If you're lucky, they might have the security guards take you out. If you're not lucky, they'll have the rubber rim people take you out. The insane asylum. Alright, so tomorrow, I gotta think about how we want to go through this, but basically I want to focus on how to analyze data. Okay, but we need to cover the fundamentals. If I were sitting where you are, I'd be totally confused, but I'd be excited about coming tomorrow. It's almost tomorrow night. But the reason I'd be excited is because there's no magic here. All we're doing is simply using 2 different streams of information. One is rate, one is pressure. We can use this really sophisticated software and generate all kinds of crazy stuff. Or we can sit down and we can talk to the data. It's also a good idea to listen. Dennis, what do you hear when you listen to the data? When you see things that are inconsistent, what do you think? Is it the data's fault? Data is nothing. It doesn't have emotions or feelings or inanimate. So it must be somebody's fault. You want to go find out whose fault it is? Okay. But right now the objective is to analyze it. I don't want to give you a data set that's actually field raw data. Why? Because there might be something wrong with it. I have an oil well from Indonesia, Thailand, somewhere I think. It's the Ataka. Is that a platform or formation? ATTAKA.
I think it was a platform.
Yeah, it's a Thai oil well. And it's a beautiful data set. Schlumberger actually used downhole gauges. And the end of it doesn't look right. And that's why they sent it to me. But the beginning of it is beautiful. What happened at the end to cause the rates and pressures to diverge? It really happened. Okay. Think very carefully everything I've told you for the last week. And glance over at that side of the room.
Facilities messed up.
Glance over at that side of the room. What's that over there?
Trailer.
Trash.
Trash can. What did we talk about?
Trash and
And the trash can goes what? The pressure drop that we don't know where it came from. So what happened is they had an extra pressure drop, and no matter how hard I tried, I couldn't match it. Until I did what? Until I applied not just the trash can, the time-dependent trash can. And I told you, don't play with the time-dependent trash can because it's plutonium, kryptonite, whatever. What could cause the later data to have a variable time trash can?
Stop producing?
Never see that. No, never see.
Went below the bubble point. had gas blocking. Because that's what I assumed. There was nothing else I could find that would explain it. Could have been asphalt beams, but more likely it was gas blocking. So something happened as a function of time, and I got no more insight than you do. You know, so I try everything my little bitty brain tells me, and I gotta come up with a conclusion. But cases like that are really cool. Now, I had another case, teaching a short course for Statoil in Norway, and they got two kinds of reservoirs in Norway. You know what kind they got? They got 1 Darcy gas and 5 Darcy oil. You talk about easy living. No wonder they're never in a hurry. What happens when you have Darcy reservoirs?
Shit stuff. Stuff happens fast.
Okay. More importantly, do you worry about water influx? But with 5 Darcy, you better worry about water influx. Because the second you cause pressure depletion, what's that water going to do? Anytime you reduce the pressure on the system, everything's going to move. These things were monstrous. The pressure data is right, correct, because they measured it, but it represents a process that's wrong. It represented the water influx, not the behavior of the reservoir. So you're sitting here trying to analyze the data, when in the background is this monster, this boogeyman, this unforeseen force. And they're just laughing at me, because they've been doing this for years. And they know you go in and turn on the constant pressure source and everything works out fine. I'm looking at this going, this is garbage. So I had the last laugh. They had just bought 250,000 acres in the Marcellus Shale. Well, they partnered with somebody, I won't say who, but you can look it up. I said, you know what the permeability is there? Oh, it does not matter, we will figure it out. The permeability is 10 times 10 to the minus 6 millidarcies. You are crazy. They had a little bit of a rough start with shale. They thought they were going to treat shale like they did. 1 Darcy gas and 5 Darcy oil. It didn't work out that way. You know why the super majors bought into the shale? Was it because they were already all gobbled up by the time they got in?
They already own they already own the big reservoirs. That's
Yeah, but why did they wait?
Because it's hard.
I've been in more than one super major doing presentations, and they've told me, we don't need to understand, we can model it. Remember the story I just told you about me and water influx? Now flip it around and take somebody who's used to doing water influx and put them in shales. You guys got to know the whole breadth. You can't get away anymore with just knowing the piece you want to know. You got to know the whole thing. And I work on low permeability stuff so much, I forget about high permeability. Somebody from Pemex sent me some wells this summer. I worked on them. You know what permeability was there? It was Darcy with a D. You know how fast things happen with Darcy with a D? Hours and days. It was not a fun exercise. You know what else happened? Their pressure gauges, they didn't work all the time. You know why? You're going to love this. Pressure gauges didn't work. Downhole gauges. Dennis, any ideas? There would just be months at a time. They would work, then they'd not work. They'd work, then they'd not work. It wasn't regular. Want to take a guess?
did they turn the well on?
Nope. It was remote, there was nobody on the platform. Okay? Except for what? Seagulls. Seagulls were using his solar panels for toilets. So they come by every month, clean off the solar panels, the gates start working again. I'm not making this up. I wish it were true, or it were true, but I'm not making it up. So there's your caveat, or your antidote of the day. So tomorrow, we meet at noon, and Kenny meets tomorrow, so you all remind me when to stop talking, because I don't want to get yelled at. And maybe we'll meet tomorrow night as well, we'll see how we feel. You guys got something tomorrow night?
Nope, we have no life.
I think you got no life. I got 4 hours of sleep. I've got 4 energy drinks today, and I like Albuquerque shoes. Thank you, Nino. Next time, let me know you got my email.
Well, I got your email online, so.
Yeah, any excuse is a good one, son. I saw my mother's tombstone.
I'll let you know in the future.
That's a good answer. Yes.
I just, there was a question lecture I remember 2 years ago, the physics graph student, I think said something about, like, an analyst, the way that things, like an analytical solution is possible if the function represented by its power series has all of the exponents as positive. Or something along those lines. Isn't that
What he's talking about is the old style solutions, which were eigenvector solutions. They had that was how they were deriving Fourier series type solutions. But don't worry about the mechanics. It's okay. This is the kind of stuff that you would develop in Math 609, or actually not Math 609, but 602 or Code 620. But what he was trying to say is that whatever the system of equations was, probably a Fourier series, that it had to have positive eigenvectors.
This was in the introductory quantum mechanics class.
Yeah. The physics guys always talk about things in terms of coefficients, and they always talk about things in terms of physical